Okay, so let me just repeat that question, because the mic may not pick your.
Somewhere where you're mixing return line number and return info all in the same algorithm.
Okay, now that has to do with the return line number versus return info. It depends on the subroutine that you're invoking. If you're invoking a subroutine that returns a value, use return info. If you're invoking a subroutine that does not return a value, then you can use return line number. Is that okay?
Yeah.
So you still want to see an example of that? Sure, we can do that. Let's go ahead and close this. Let's start a new sample program. Okay, so the easiest way to do it is to do something like this. Okay, define sub 5. Okay, return the value 5, and define sub. So this is pretty much as simple a subroutine as I can make it that returns a value. And then we have define sub. Stub is a stub subroutine, and all it does is to print invoke 5, and that's all it does. So now we have two subroutines. One has a return statement, and the other one does not have a return statement. Is that okay so far? As far as the main program is concerned, or the code outside of any subroutine definition is concerned, all it does is to invoke stub as a stub subroutine. So this will illustrate when to use return value, return line number, and when to use return info. So let's go ahead and trace this code. This will be a pretty quick trace here. We don't need comments because there are, we do because we have a print here, so we do need the comments to indicate when something is printed. We have line number. We don't have any global variables to deal with, so the precondition is really easy to state. The first line to execute is line 7. That's the only line outside of the definition of a subroutine. Invoke stub. So let's ask the question. Should we use return line number or should we use return info in this case?
Return line number.
Return line number because the subroutine being invoked, which is stub, does not return a value. Okay? So here we use return line number. And where do we go back to after line 7? Post, because there's nothing else after this. Very good. So now that we have column C set up, we can go into subroutine stub and start executing on line 5. Line 5 says we want to print the value of invoke 5. Okay. That means we have to invoke subroutine 5 first. When we invoke subroutine 5, we have to use one of the two. Which one should we use?
Return info.
Return info this case because the subroutine being invoked is 5, and 5 does have a return value. So now we have to say return info, and what do we put inside the return info thing?
5.
We have to go back to line 5.
Question mark.
Exactly. Okay. The question mark is once again a placeholder because when 5 returns a value, that value will resolve what the question mark is supposed to be. So am I partially answering your question right now?
Yes.
Okay. But we'll go ahead and finish this. It's really trivial to finish the entire thing. So now that we have column D set up, we can go into the subroutine. Subroutine 5 only has one statement to execute, which is line 2. Line 2 is a return statement. Just with any return statement, you copy and paste the return info cell, you change the question mark to the value that we are returning, which in this case is 5, and we're done with the return statement. Then we go to line 3. Line 3 is going to end the execution of the subroutine. So the first thing it has to do is to look up return info and tell us where we're supposed to go to continue execution, which is line 5. And then we'll go ahead and deallocate this column. Okay, any questions? Now when we do get back to line 5 looks like this. So that means there's nothing else to do except to finish up the entire statement on line 5, printing a value of 5. After line 5, we get to line 6, which is the end of subroutine stub. And to do that, we have to look up its own return line number, which reminds us that we have to continue execution at post. But at the same time, we also have to remember to deallocate this column. even though there's no other code after this, we still have to remember to deallocate everything, because that's just what a program is supposed to do. So is that okay?
Yes.
Okay, excellent. Any other questions? Let me just save the file first. So think of another thing, another topic you want me to go over again. I'll call this one return line number, return info, because it helps to clarify, when to use one and when to use the other. Any other concepts that you want me to go over? Yes.
What about like a loop within a loop?
A loop within a loop. We can do that. First. Okay, if you want to do a loop within a loop, we can do anything else you want to go with that. I mean,
Well, what about like a conditional or whatever? Is that where like it splits and then it beats back up
that's a conditional statement
with a loop on one side?
with a loop on one side. Okay, let me ask you another question. Do you want the conditional statement to be in the loop? Is that what you want? I mean,
Sure, that'll work.
so conditional statement in a loop.
Yeah.
Okay, very good. We
Put
can
some
do
other
that.
stuff in there too.
Huh?
Put,
Sorry?
put some records and then pass it by reference.
Let's add two arrays.
This is not Subway, okay? It's not Subway. I want lettuce and tomato, honey mustard, and oh yeah, but no onions. Okay, so we can do this with or without defined sub. Let's do it inside the subroutine. Yeah. We have, let's say, local variable, x. Now that we know what the type is, let's go ahead and spell out the types all the time. Okay, that's good. Local I is an integer, so I would say I is initialized to 0. And let's say while I is less than 5 this time. 2. And now we have a conditional statement. So I'll make this kind of, it's not going to be too confusing in this case. While I mod 2 equals to 0, and x gets x plus 1. I have to initialize x2 because I have not done it yet. Else if I mod 3 equals to 0, then x y gets y plus 1, and if I gets I plus 1, and while stub. And I forgot 2 other things to do, which is here. X gets initialized to 0, y gets initialized to 0. Now all we have to do is to fix the indentation. I could write a script in Python to actually automatically do the indentation, because I can write a script to identify what each line is, and it can just scan through the whole thing and do all the right indentation and whatnot. One thing you can do with Python, is to use OpenOffice as a platform to test, Python programming. Python is kind of like VBA in OpenOffice. You can actually write scripts in Python inside OpenOffice. So it's a kind of like a built-in platform to play with Python. But you might have more problems finding, documentation for that because it's not as well documented. All right, so this, this way we have a little sample program to go through conditional statement, a compound or multi-branch conditional statement inside a loop. Excuse me. And to trace this one, the most important part is to identify where is the end of each construct. Okay, let's go to sheet 2 and we do need comments because we have few conditions to deal with in this case. And we have line number. There are no global variables, so precondition is easy to state. On line 17, we invoke the stub subroutine. When we invoke the stub subroutine this time, should we use return line number or return info?
Line number.
Return line number because stub does not return a value. Okay, very good. So we'll say return line number, which is post, because line 17 is the last line of the program. But we also have to set up the other stuff, which is local variable x, local variable y, and local variable I. Since they're all local variables, they all start with unknown values. And that's why I have the initializations before the loop, so that I know by the time I get into the loop, they start with some reasonable values. Once the columns are set up, I go into the subroutine starting on line 5. Yep.
Like on what is it? On row 5, like when you're initializing all those variables, are you able to condense it into like one row itself by initializing all of them to 0 all at once instead of separately, like what you can do in Java?
Oh, you mean initializing when you declare the variable?
Yeah.
You can do that.
Okay.
It's just that in this class, I don't really want to get into that.
Okay.
In most languages, you can do that. You can say local x equals 0 : integer or something along that line.
But even when we're dealing with pseudocode, we could do that as well.
You could, but it kind of masks the fact that if you did not do that, a local variable starts with an unknown value. So I want to kind of emphasize the fact that if you don't initialize, a local variable has some unknown value.
Okay.
So in this class, I just want to kind of overemphasize that part and not to use the shorthand to initialize local variables.
Okay.
Yep.
I think he's saying, or are you saying like you want to just have x, y, and I all be on one line?
Yeah, one line equals 0.
Okay.
Yeah.
So he's still understanding
Oh,
the
okay.
concept.
Yeah,
So
I'm
you are
not-
talking about something like this.
About like line 5, 6.
Yeah, like that.
That's that is a little bit hard to understand because it relies on the fact that this expression returns a value of 0, which then can be used by this expression, which also returns a value of 0. Then it can be used by the overall statement. So to do something like this, we are basically relying on the fact that an assignment operation is not a statement; it is actually just an operator.
Okay.
And that's not something that I want to kind of go over in this class. We just look at assignment as a statement and not an operator in this class. Even though it is an operator, but to look at it as an operator can be really tricky because you can put it inside the conditional state, inside the condition of a conditional statement as well.
Okay.
So that's why I just I'm trying to avoid those concepts in case people get into confusion. But you are correct. I could combine all of that onto a single line or do it as I declare the variable too. And there's also a shorthand that is not available in, say, Visual Basic. In Visual Basic, you can only initialize one thing at a time because assignment is a statement. It's not an operator. Okay. So on line 5, so we are going to be a little bit more tedious in this case. We have to initialize each variable on a different line. So line 7. Okay. And then on line 8, this one is easy. It doesn't even have bar something bar. I is 0. 0 is less than 5 is true. Then we go to line 9. Okay. Line 9, is asking a question. There's a condition to evaluate. I mod 2 equals to 0 is it true or is it false? I is 0. What is 0 mod 2?
0.
0 mod 2 is 0. And 0 is true. Is everybody convinced that that is the case? 0 mod 2 is the remainder of 0 divided by 2.
Okay.
Okay, and that really is 0. And 0 equals 0 is true. That's why we have to go to line 10. Line 10 is adding 1 to x. X goes from 0 to 1. And, it's also going to make line 11 true, the condition of line 11 true. Should we go there?
No.
No. It is a multi-branch conditional statement. Once you take one branch, you get out of the multi-branch conditional statement. So we don't go to line 11 at all. We don't even evaluate that condition. We go straight to line 14. Oops. Okay, that is important. Okay, we go straight to line 14, even though there are additional conditions that are true. Once you take one branch, you get out of the multi-branch conditional statement. On line 14, we just add 1 to I. I goes from 0 to 1. And because line 14 is the last line of the loop, we go back to line 8 to reevaluate the condition. I is now 1. 1 is less than 5 is true. We go to line 9 again. Line 9 is asking 1 mod 2 equals to 0 is
False.
It's false because 1 mod 2 is 1. 1 divided by 2 has a remainder of 1. Okay, if the condition of line 9 is false, then we go to line 11 to evaluate its own condition. And that is 1 mod 3 is 0 is
False.
false. Okay, so we don't execute any branch of the multi-branch conditional statement, which is fine. It's not a problem. We go to line 14. Line 14 is going to add 1 to I. I goes from 1 to 2. Then we go back to line 8 again. I is now 2. 2 is less than 5 is true. So we go to line 9 again. I is now 2. 2 mod 2 is 0 is true. We go to line 10. We add 1 to x. X goes from 1 to 2. Then we get out of the multi-branch conditional statement. We go to line 14. Line 14 is adding 1 to I. I goes from 2 to 3. And I think I have to split the screen vertically. That's good.
And now we're back at what, 8?
We're going back to line 8. Line 8 is I is less than 5 is true because I has a value of 3 at this point. We go to line 9 again. 3 mod 2 equals to 0 is false because 3 mod 2 is 1. Very good. Then we go to line 11. Line 11 is asking 3 mod 3 equals to 0 is true. Then we go to line 12 the first time and the only time. Y gets incremented from 0 to 1. Then we get out of the multi-branch conditional statement. We continue on to line 14. It adds 1 to I. I goes from 3 to 4. Then we go back to the beginning on line 8. 4 is less than 5 is true. But this is the last time this condition is true. We go to line 9. I mod 2 equals to 0 is true because 4 divided by 2 has a remainder of 0. Then we go to line 10. We add 1 to x. X goes from 2 to 3. We get out of the multi-branch conditional statement. What? Did I make a mistake?
Oh no, yeah, we get out of it and then we go to 14.
Yep, we have to go to line 14. We add 1 to I. I goes from 4 to 5.
Then we get out of the while. Or no,
We don't get out yet.
We go check the while.
You have to check first, exactly. You have to go back to line 8 first, then you can get out. So we get back to line 8. I is 5 this time. 5 is less than 5 is false. Then you can get out of the loop. So by the time we get out of the loop, we continue on to line 16. Line 16 is end define sub. It has two things to do. First, to look up return line number, to remember where we are supposed to go next. Then it is time for us to deallocate the 4 columns. So, and by the time we get back to post, that means we have nothing else to do and we are done. Okay. Is that working out okay? Did it illustrate what you wanted me to illustrate earlier? Okay. So it's really go ahead.
In the if statement, sometimes you do the one, sometimes you do the other, and sometimes you do none of them.
Mm-hmm.
Okay.
Well, it depends on how the multi-branch conditional statement is set up. Because in this case, I don't have else, which is a catch-all case. So that's why sometimes there's nothing to do, because if I mod 2 does not equal to 0, and I mod 3 does not equal to 0, there's nothing to do. There's no branch corresponding to the rest, quote unquote, the rest.
So unless it just says else.
The else is a catch-all.
Okay.
If none of the conditions of the other branches match, then you go to the else.
Okay.
And to understand that, you can also draw a picture of the multi-branch conditional statement. Then you can see that the else is the very, very last.
What would a picture look like without an else?
Without an else, like this one.
Yeah.
The picture in this case, do you guys want me to turn on the light, or can you still see it without the light?
I can see it.
You can see it? Okay. So in this case, the multi-branch conditional statement has one branch first, and the first branch is asking, I mod 2 equals to 0. Okay? And if it is true, we go to one side, which is adding 1 to x. So x gets x plus 1. If it is false, we go to the other side. Now the other side has another question to ask, which is the second condition to ask on line 11. So on line 11, in this case, we have I mod 3 equals to 0. It's either true or it is false. If it is true, we have one more thing to do. We have y gets y plus 1. If it is false, there's nothing to do. So that means all of these paths will merge at the very end, and this one has nothing to do, but it will still merge to the very end.
And then it would go back up to the while again, right?
Right, but the while is not represented in this picture.
Okay.
So if you take this block here, that entire block is line 9 to line 13.
Okay.
Is that okay? Okay, so this is all done. Let me save the file, and then we can move on to the next one. I'll call this mod 2, mod 3. I think it'll be cool to make a little emblem, like mod 3, instead of Mach 3. The Mustangs, have Mach 2, Mach 3, and whatnot. So instead of Mach, M-A-C-H, which is one Mach is at the speed of sound, right?
Yeah,
Mach 2 is twice the speed of sound. We have mod 2 and mod 3. Let's see if people actually spot it. Okay, any other questions? Any other concepts that you want me to go over? Because this is a good day to do that, if we don't have anything else to do. I cannot let you guys go anyway until 11:05. So if you have any concept that you want me to go over, to clarify, or to illustrate again using a sample program, this is the time to do it.
We got 10 minutes.
According to the clock.
When you say simple, how simple do you mean?
Huh?
How simple of a program do you want?
No, concept. I want you guys to tell me what concept you want me to go over again. Yep.
Do you have a rough idea of what's going to be on the final exam at least, so that we can kind of figure out what?
It is comprehensive, so everything that we talk about in this class, except for the things that I explicitly said it won't be in the final exam, will be in the final exam.
Okay.
Yep. So it's comprehensive. We'll have pre and post conditions again. Do you guys want me to go over that? No?
Yes.
Yeah.
I don't want to see that again until the final exam. Avoidance is not necessarily useful in this case. Okay, let's go through some of those things, pre and post conditions. All right, so we'll go ahead and start with the basics. Okay, the basics, would be, the first one would be assignment statements. So for some reason, line 23 looks like this. Okay, let's say x gets a value of k. Okay, doesn't matter what it is. Okay, it's just k. So what I need to tell you is, what is the precondition of line 23? So the precondition is what we know for sure before line 23 executes. Line 23 in this case is just a part of a much larger program, but I'm only focusing on one line at a time. So for whatever reason, line pre-23 is to know that y equals to 20 and z is less than 5 and x equals to another variable, let's say, I don't know, w. Okay, so this is what we know before line 23 for sure. Okay, it's already proven by all the other statements, by all the other lines, and so on and so forth. This is what we know. The question is, what do we know after line 23, which is what we call the postcondition of line 23? That's the question. Okay. First of all, what kind of statement is this? Is this a loop? Is this a conditional statement? Or is this an assignment statement?
Assignment.
It's an assignment statement. Okay, we are changing the value of a variable. So if that is the case, there are only two rules that we can apply. One is the forget rule, and the other one is the substitution rule. The difference between those two is one needs the right-hand side to be a reversible function of the variable on the left-hand side, and the other one does not. So let me ask you a question. If I define a function, let's say function f of x is k, is it reversible? Is there a way for me to go from k back into x?
No.
There's no way. Okay? Well, there's no way because this will map anything to k. F of 1 is k, f of 2 is k, f of 2000 is k. So once you know, even though you know that x equals to k after this, there's no way to go back and say, oh, okay, but from here I can go back and know what x was before the statement. There's no way to reverse it. So if we cannot reverse the operation, which rule should we use?
Forget.
The forget rule. Very good. So you guys are pretty good. That's good memory. It's quite a few weeks ago when we last talked about this. Okay, so we'll go ahead and explain that first. Okay, we'll say the right-hand side of line 23 does not refer to the left-hand side, so we can use the forget rule. Because if the right-hand side does not refer to the left-hand side, we know for sure it is not reversible. Okay, this is definitely telling us that it is not reversible. So how do we apply the forget rule? We say post-23 is kind of based on pre-23, but we have to forget certain components. We have to forget components that mention what?
The right-hand side.
The left-hand side.
The left-hand side.
So in this case, the left-hand side is which variable?
X.
X. Mm-hmm. But after we do all the forgetting of what we know already, there's one thing extra that we know for sure now. What is that one extra thing?
K. X equals K.
X equals K. Now, it is very important that we state that X equals K and not to say that X gets K. Okay, these two things are entirely different. This one here is an operation. It is telling you to copy the value of K to X. It is not a mathematical statement. It's not stating that X equals K at this point. So this is not what we want. Okay, that is not what we want. This is what we want, because we want to state that X equals K is now true. Does everybody understand the differences between those two things? Okay? Now that is very important, because I have seen a lot of people using the assignment operation inside the condition, which does not make any sense. Okay? So let's go ahead and expand what is pre-23. So we'll go ahead and say, okay, pre-23 in this case is helpful to use an editor because I can just copy and paste it. And we're forgetting all components that mention X. And then after that we say X equals K. Okay, let's take a look at this highlighted portion here. which one mentions something about x?
Last one.
The last one, so that's the one that we'll toss, okay? Because we can keep these two. These two do not mention anything about x. In other words, changing x will have no impact to the fact that y equals 20 or the fact that z is less than 5. So this is the result. This is post 23. Post 23 is we can keep the fact that y equals 20. We can keep the fact that z is less than 5. But we don't know whether x equals w anymore. But on the other side, on the other hand, we also know that x equals k because we just change x to become k. So are there any questions? The notation is one thing, the rationale is one thing, but I think the most important part is to understand why we want to do this. Okay, why can we go from the precondition of line 23 to the postcondition of line 23? Is that doing okay so far with this? Okay. Just gonna assume that it is yes. If you guys have any questions, we can always come back and look at this again.
Can we ask some questions on the day of the test?
You can always ask questions.
Usually good answers.
Yeah.
Not the answer that you want. Okay, so let's try something else that is reversible. Okay, we'll start with something that is relatively easy to illustrate the concept. Let's say this is line 67. Line 67 says z gets z times 2. Okay, that's the statement. It doubles the value of z. Let's say before line 67, we know a few things. We know that z is less than k, and y equals x, and also, z is greater than w. Okay, so those are the things that we know before line 67 executes. Okay, so the question is, what can I say about all these variables after line 67? That's the question. Well, one thing is, do we know after line 67 whether z is less than k? No, we can't. But after line 67, we can say z divided by 2 still has to be less than k. Because line 67 just doubled the value of z. So if I have that again, I will get back to the original value of z, which was less than k. So that's the whole idea behind the substitution rule and the whole concept of function inverses is to basically undo the operation on that line so that we can reestablish the same relationship that we know before. So that's the whole concept, that's the whole idea of the substitution rule. So in this case, what we can say is the right-hand side of line 67 refers to the left-hand side. And then what we can also say is f of z equals z times 2 is reversible. Okay, it is reversible, or you can say it's an inverse, whichever way you want to say is fine. In fact, we can also state what is the inverse function. The inverse function f prime of z is what?
Z divided by 2.
Is z divided by 2. Very good. Okay, so that's why we can use the substitution rule. The substitution rule says the postcondition of this line depends on the precondition, but we have to do some substitution operation in the process. We use the precondition as a starting point. We identify all references to z, and then we change each reference to z by the inverse function of f applied to z. Okay. So the next step is really just to expand, what is pre-67. We'll just go ahead and copy and paste it. And then we identify which one we are replacing, and we identify what we are replacing it with. And here we can just refer to that as z divided by 2. Okay. Are there any questions at this point? No? This is good? Okay. So now we just have to go ahead and apply the substitution. Oh, here's one z. So what you do is whenever you see z, you replace it with z divided by 2. So now it becomes z divided by 2 is less than k. Y equals x is the same because none of these two refer to z. And z divided by 2 is greater than w. That's pretty much the answer. Okay, if you want to take it one step further, I'm not even sure, it is a better way to say it, but you can also say that z is now less than 2k, and y equals x, and z is greater than 2w. It is really the same thing, it's just, moving a divide by 2 to the other side to multiply by 2. Okay? But is the rationale understood, why, this is useful? So that's the substitution rule. And now we can move on to conditional statements. With conditional statements, it's a multi-line kind of deal. We'll say this is line 31. Line 31 says, if x is less than y, we can make it more complicated. You can just, stack some more stuff to it. Let's deal with this one first. It does not have an else, okay? It just has a then portion. In other words, we execute line 32 if this condition is true, but if this condition is false, there's absolutely nothing to do. Okay? And in this case, let's say that before line 31, we know something. We know something that may have nothing to do with the condition of the conditional statement. Let's say we know something about y. Okay, we say we know that y has a value of 16 in this case. That's all that we know before this statement. So how do we go forward from the precondition of line 31? Well, what about line 32? Can we say something about the precondition of line 32? In other words, if we are about to execute line 32, what do we know right before the execution of line 32? What can get me to line 32? The condition has to be true, okay? The condition of the conditional statement has to be true, but since I did not have a chance to modify x, y, or z, that means pre-31 also has to be true. So the precondition of line 32 is the same as the precondition of line 31, and on top of that, we also know that x is less than y, and y is less than z, which is the condition of the conditional statement. Because if the condition of the conditional statement is not true, if it is false, I would never even I would not even go to line 32. Is that okay so far? So if I just expand this, it just says that y equals 16, and x is less than y, and y is less than z. That's the precondition of line 32. Are we doing okay so far? Okay. Now we can move on to line 32. What is the postcondition of line 32? Well, if you just look at line 32, you can take it out of the context that this is inside the conditional statement, because it is just an assignment statement itself. And if it is an assignment statement, you can only apply either the forget rule or the substitution rule. In this case, which one should we use? We have to use the forget. We have to use the forget rule because the right-hand side of line 32 does not refer to the left-hand side. That's a done deal. Okay, if the right-hand side does not refer to the left-hand side, it's definitely not going to be reversible. Okay, so use forget rule. So that means the post 32 is based on the forget operation of pre-32. Anything that mentions k needs to be forgotten. But after this, we also know that k equals 4. Now in this case, there's really not much to do because pre-32 is this mess here, but this mess does not mention anything about k, so there's nothing to forget in this case. So that means after the forget operation, we get the whole thing back, and then on top of that, we now know k equals 4. Is everybody okay, with post 32, the post condition of line 32? Is that good? Okay. So here comes the end of the whole thing, which is what is post 33. How can we get to the end of this merge point here? Well, not of this conditional statement, but how do we get to the merge point of that conditional statement? That's the question. There are two ways to get there. One way to get there is after line 32, because after line 32, we get to the end of the conditional statement. What is the other path to get to the end of this conditional statement?
If the first statement, if 31 is not true.
If the condition of line 31 is not true, we go straight to the end of the entire thing. So that means the post condition of the entire conditional statement is a disjunction of two things. Okay? So something or something. The first one is this one here. You can make it the first or the second, it doesn't matter which way. Okay? The other one is the condition of the conditional statement is false. So the other one, you can also just say that it is not the case that x is less than y and y is less than z. Okay? But there's something else, because that also means that we did not have a chance to change anything. So in that case, you also have to say that and y equals 16. So y equals 16 is true in both cases. Does that make sense?
Because you couldn't have got there unless.
Right. Well, if I skip the whole thing, I did not have a chance to change y either. So if y equals to 16 was true, it has to be true still at this point.
Okay.
Okay. If I put a line break somewhere, it's easier to see.
Why couldn't you just say x is less than 16, not x is less than 16 and
You could do that if you want.
And z is greater than 16 or
Yeah,
whatever.
you can do that.
Okay.
Yeah. But if I just use the forget rule and the substitution rule without doing all the symbolic manipulation, this is what I should get.
Okay.
Okay. Is that all right? In terms of concepts? And I will not ask you questions about the post condition of loops, so don't worry about loops, because with loops the difficult part is how do you get the loop invariant? That's the difficult part of loops, and that's kind of kind of outside of the scope of this class. Okay, so that's another one. All right, let's take a look at a reversible function, except it is a little bit more difficult. Let's say this is line 32. Line 32 says that x gets x times 3 plus 2. Okay? And we'll make this really simple. We'll say the precondition of line 52 is that x has a value of I don't want it to make it a constant, because if I made it a constant, then some people will try to trace it and get it done that way. So I don't want to make it a constant. Let me just make it a k. Okay. So the question is, what is post 52? The first question you have to ask yourself is it reversible? Okay. Is the right-hand side of line 52 reversible? Okay.
Yes.
It is reversible. Okay, it is reversible. So the question now is, if f of x is 3x plus 2, what is the inverse function of that?
It's x divided by 3 minus 2. No.
You have to change the operation. X minus 2, the whole thing divided by 3.
Oh, okay.
Okay. Now we can check, whether it is correct or not. Okay, it's actually easy to check. because what we want is f of f prime of x that should equal to x. Okay. So this is the case if and only if f prime is an inverse of f. So we can check. I mean, we can just plug in the numbers and see, plug in the equations and see whether it works out or not. So now we just go ahead and plug it in. F is just saying 3 times something plus 2. So is that okay so far? How I got from the left-hand side to the right-hand side? Because f prime of x is just so happens to be whatever is inside the parentheses of f. So I just take that and say, oh, we'll multiply that by 3 and then add 2 to it. So now we can expand the second level. So it is 3 times, in this case, x minus 2 divided by 3, the whole thing plus 2. Is that okay? Because f prime of x, this part here, is just this part here. But I have to remember to put it inside parentheses so that I apply the multiplication by 3 first before I add the 2 at the end. So now, can we simplify this whole thing?
Yeah.
Well, the 3 multiply by 3 cancels out the division by 3. So now we have x minus 2, the whole thing plus 2, and that just 2. That's just x. In other words, I just verified, the f prime is in fact the inverse function of the f. Okay. So with that in mind, the rest of this is really easy because we can now know that since the right-hand side of line 52 is reversible, we use the substitution rule. So that means, post 52 is based on the substitution applied to pre 52. We take all occurrences of x, replace each one by f prime applied to x, and then we just take the original, the pre 52 x, and then f prime of x is x minus 2 divided by 3, and then we just apply the substitution, which is just x minus 2 divided by 3 equals to k. If you want to do some simplification, if you want x on one side, you can definitely do that, because what you can do is to say x minus 2 equals 3k, and if you want to move everything to one single side, you can say x equals 3k plus 2. That part is just algebra. Yeah. Any questions about this? Now, if you see something like this, where it is not a simple thing, when you see the right-hand side involves multiplication and addition, multiple steps, is there a way to make this easier? There is a way to make it easier because you can always separate those operations. In other words, what you can do is to look at this not as one single assignment statement, but instead look at it as 2 assignment statements. So you can basically say, okay, I'll break it up to 52A, and line 52A is just going to take care of the first part, which is multiplied by 3, and in line 52B to take care of the second part, which is x plus 2. Is everyone convinced that 52A and 52B combined is going to do exactly what line 52 is going to do? Is that okay? But finding the inverse of multiply by 3 is easy. It's just divide by 3. Finding the inverse of plus 2 is easy. It's just minus 2. So this way you can break up, a single assignment statement into multiple steps to help you find the inverse function of the whole thing. Is that working out okay? Sort of? Okay. All right. So we'll go ahead and just borrow this one more time. Okay. We'll take this one and use this one more time. And this time I'll give you the postcondition, and you guys have to tell me what is the precondition. Okay. Should be relatively easy. If I tell you post 52 is x equals v, okay, whatever v is, okay, how do I get back to 352? So this time we are reversing, okay, we are reversing. First of all, do you think it is possible? If I tell you what x is after line 52, can you somehow figure out what is the value of x before line 52? It's definitely possible. So how do we do it? Well, this one turns out to be, an application of the substitution rule too, except this time we substitute post 52. We take a look at post 52, and then we take all occurrences of x and replace it with not f of x, not f prime of x, but f of x itself. Okay, so f prime of x to go this way, f of x to go the opposite way. Okay. So that means we take a look at x equals v. We substitute x with f of x, which is 3x plus 2, and the result becomes 3x plus 2 equals v. Or if you prefer, you can say x equals v minus 2 the whole thing divided by 3. Whoa, does that work? I mean, does it look like that this is going to work out correctly? Let's give it a try, okay? Let's give it a try. Okay, let's give this piece in. Okay, so let's just say that x equals to 352 is, so this time if I make it a solid value like x equals 2, it makes it possible to find out exactly what is the value after that, right? What would that be? 2 times 3 is 6. 6 plus 2 is 8. Okay? So the question now is, if I plug 8 in here, do we get 2 back? 8 minus 2 is 6. 6 divided by 3 is
2.
So it works. Okay. Now, why would I do something like this? Why do I care? Well, if your program crashes at at some line like let's say line 53, and by the time it crashes, the only thing you can find out is x has a value of 8. You don't have to run the program again to figure out that on line 52, before line 52, x must have a value of 2, and you can go backward like this, step by step, until such time you encounter something that has to apply the forget rule. Because when you have a forget rule, you really cannot go on much further beyond that point, because you start to lose information when you have forget rules. So this way, you can debug a program without having to run the program again and debug it line by line, because you can track backwards up to a certain point at least, and then at that point you will have to run the debugger again, because you would have at some point there are so many ways to go after that you have to actually put a breakpoint in the debugger to stop the program, and then you have to take a look at the values of the variables at that point. Okay. Any other questions about pre and post conditions? I think I have covered all the basics of pre and post conditions. It makes you think, okay, the whole purpose of the pre and post condition thing is to make you really think about the statements and the logic of your program, so that when you encounter a problem, you can try to analyze the source of the problem instead of just, oh, okay, I will make some changes and hope the program will work now. Yep.
When we're going from a postcondition to a precondition, where do you want us to stop? Or do you want us to stop when you have just a single variable on one side?
No, you can stop just here.
Okay.
Yep. Okay. Any other questions about preconditions and post conditions? Excuse me. Questions? Now, in this class, have we talked about the concept of time complexity? How much time it takes for a certain algorithm to solve a problem?
Yeah.
You did? Okay. It's not something that will be tested. I won't ask any questions about time complexity. I just thought that it was an important concept to cover so that when you guys move on to the next class, let's say your instructor tells you, okay, you have to write an assignment or you have to write a program to sort an array, you know how to evaluate different sorting algorithms. Do you guys still remember that part? Okay, let me just kind of go back and talk about that part. Unless you guys have any questions about the content of this class, I will just go ahead and review that part. So we are talking about sorting algorithms, and there are many. Okay, if you go to Wikipedia, there are many sorting algorithms already documented in Wikipedia. You have selection sort, bubble sort, tree sort, heap sort, and so on and so forth. And there's a big old notation. Forget about the big old notation for the time being. And what we want to do is we can compare the sorting algorithms. Okay, so here's the comparison chart. Let's just say that we don't care about memory and the other parts here. What we care is how long does it take to sort an algorithm. In this case, n is the size of the problem. In other words, n is our bar A bar. That's the number of elements in the array that you're supposed to sort. Best, average, and worst, they are called time complexity. They are basically saying, how does the size of the problem, which is n, affect the amount of time it takes to sort the array. So with quicksort, the best case and for the average case, the amount of time it takes to solve the problem is proportional to n times log n, which is as good as any sorting algorithm can get for the best and average case. But the worst case is really bad because the worst case is n squared, which means it is no better than bubble sort. Bubble sort is also an n squared type of algorithm. When you look at Mergesort and Heapsort, they are cool, because you can see n log n across the best, average, and worst case. So that means, if you want your sorting algorithm to have a predictable amount of time to solve the problem, you don't want to pick quicksort, because quicksort has a worst case scenario that is much worse than the best or the average case. On the other hand, if you look at Mergesort and Heapsort, they are much better because, they are n log n across the entire thing. Is that reasoning working out? Okay. Now, so in this class, or at least at this point, we don't really care about the algorithm itself. We are just looking at, how efficient is the algorithm, and also how reliable is that efficiency. We talked about selection sort. Selection sort is one of the worst algorithms you can pick, because it is n squared across the entire thing. So that means it is slow regardless. Okay, the best case, the average case, and the worst case are all way too slow. And then you have some strange algorithms, tim sort, shell sort, and so on and so forth, that has a complexity of n in the best case. Do you really care that much about the best case when you're sorting an algorithm, when you're sorting an array? Sometimes you do, and sometimes you don't. The n here for bubble sort is assuming that your array is already sorted except for one element. Okay, if the entire array is sorted except for one element, it will only take one pass for bubble sort to go through the whole thing and confirm that everything is done. And that's why you have a time complexity of n for the best case with bubble sort. But what are the chances that will happen? Depends. Okay, if you are guaranteed that your array is always sorted except for one element, then go ahead and use bubble sort, because the best time scenario is only n. On the other hand, if you are given an array and you have no idea what is the content in the array or how badly it is randomized, then you don't want to use bubble sort, because you will hit the n squared scenarios pretty easily. Is that okay so far? Now you can scroll this down. You can see all the other sorting algorithms too. Some of these I haven't even heard of. Okay, like comb sort, gnome sort. What is gnome sort? I mean, I guess I can always click it and find out. How a gnome sort an array.
Stupid sort.
Stupid sort. Okay, originally proposed by Hamid Sabazi Azad in 2000 and called stupid sort, and later on described by Dick Ruin and named gnome sort. It's a sorting algorithm which is similar to insertion sort, except moving an element to its proper place is accomplished by a series of swaps, as in bubble sort. Okay, so we don't really hear much about these sorting algorithms because of the worst case scenario or the average case scenario being so bad to begin with. Okay, so this is something that you should be aware of. Is even though we are just talking about how to sort an array, there are these many algorithms already available for you to choose. So the question now is, how do you choose your algorithm? You don't have to reinvent the wheel. Okay, when someone asks you to write an algorithm to sort an array, you don't have to start the whole thing from scratch because there are these things that you can select from already. Each one, or even the best ones. Okay, let me show you the best ones. Okay, the best ones, particularly with merge sort and heap sort. These two. Okay. Merge sort and heap sort, they are both very good sorting algorithms because you can see the best, average, and worst case, they're all n log n, which means how much time it takes to sort an array is completely predictable. If you know bar a bar, you know how long it will take, which is a good thing because you can always predict how long it will take to sort to sort an array. So which one should we use? Well, it depends on something. I mean, certain things we haven't really talked about in this class, but I would just kind of briefly mention that so that you understand all the additional considerations that you have to kind of think about when you select a particular algorithm. Merge sort is a very interesting sort algorithm. Do you guys still remember in Star Trek, the original Star Trek, what do those computers look like in the original Star Trek? They have, they have tapes, right? The old computers use tape to, store data. That's their mass store. That's their critical hard drive. What is one big disadvantage of a tape, storage device compared to a disk like a hard drive?
You can fast forward or rewind all the way to where.
Exactly. To locate a particular thing takes a long time. It's just like VHS tape versus DVD. In DVD, if you want to skip to a certain chapter, you're there. What if you're using VHS tape? It takes a while, okay? And that's the same problem with tape, versus hard drive too. Hard drives, very easy to random access. I want to get to this part of the file, instantly you're there. If you use tape, it will take you a bit of time to get to that portion. So you would think that if you want to sort, let's say, 20 million records stored on tape, think about that. Okay, you have 20 million records stored on tape. It is not sorted. How would you sort that? 20 million records. Well, as it turns out, merge sort is very good with that sort of thing. Now, merge sort also has the advantage of it does not require a lot of memory. If you have 20 million records to sort, merge sort only needs to store 2 records. It only needs enough space to store 2 records out of 20 million in order to run. And it runs extremely efficiently with tapes. What you need is 3 tape drives with merge sort, and it will do it in a very short amount of time. As short as it can possibly be. Heap sort is really good when you have arrays. Okay, if you can random access, really easily. In other words, I can get to, A bracket, 20. I can get to A bracket 2000, just like that. If you can do that, heap sort is a really good algorithm because it can do sorting in place. It does not require a temporary array to store the sorted version of the array. So those are the considerations. We haven't really talked about those other things, in this class, but those are the things that you need to consider when you select a particular algorithm to sort an array. Any questions about this part? Yep.
So do programmers memorize these methods of sorting, or do they have handbooks in order to kind of reference to when they're needing to sort like this?
Well, at some point you're going to take a class, called algorithm analysis, and in that class, they will kind of go through some of these, and kind of talk about it. But for the most part, by the time you become a programmer, or a few years, after you become a programmer, you just be familiarized with the restrictions. I don't have a lot of memory. I cannot store the entire array in memory. Then you don't have a choice. You cannot do heap sort unless you can store the entire array into the memory of a system. But merge sort does not require that, so you have no choice but to use merge sort in that case. Did I answer your question? Okay. Wikipedia is great. Before Wikipedia, it's really hard to find a place where all the different algorithms are listed and compared. But now with Wikipedia, it becomes just a click to get to this page here, and as long as you understand what these terms mean, you're all set. Okay. Are there any other questions about algorithms, how to select an algorithm? What about questions of writing your own algorithm, which is something that we have not done in this class at all? There is no assignment that we have done that requires you to come up with an algorithm to solve a specific problem. So the question is, how do we do it? In your next class, you will have homework assignments like that. You will be asked, someone will give you a sheet of paper, which describes the proper behavior of a program. And what do you do to write a program that will do exactly what the assignment is asking? Where do you start? Or I should change the question. How do you get started? Some people sit down and fire up either Visual Basic or the C development environment and start typing away. Don't do that. Okay? Do not do that. The first thing you want to do is go through the logic specified in the homework assignment and try to do it manually, using a piece of paper. Okay? That's always the first step, is try to do it manually so that you understand what the program is supposed to do. Don't start with writing the program right away. Start with doing it manually. Now, if you try to do it manually at a certain step and you cannot go any further because it is not clear whether I should do this or I should do that, then you should stop right there. Go back to the instructor and ask the instructor, okay, this is the case I'm trying to use. I'm at this step here. I do not know if the instruction is not clear which way to go. And that's why you have to do it manually first, just so that you understand the logic. If you can do it manually without any questions, then you can start to write it in using the code, using C or Visual Basic. Okay, when you write a program, it is easier than writing a paper because you only have so many types of statements to start with, and each type of statement has its own purpose in life. What is the purpose of an assignment statement? It's very simple. There's only one purpose of an assignment statement.
Change the value.
Change the value of a single variable. What about the purpose of a conditional statement? If then else, if then else if, else if.
Assess a value.
It's a selector, okay? It's kind of like a switch thing. So you can say, okay, sometimes we want to go this way, sometimes we want to go this way, or this way, depending on one or more conditions. Okay? So that's the job of a conditional statement, is to say, okay, at this point, sometimes I want to go here, I want to go here, I want to go here, or I want to go here. But guess what? Every single branch that you take will merge at the very end and continue execution after that. A conditional statement is not a loop. It does not go back to the beginning to do something again and again. So that leaves us only one type of statements left, the loops. Okay, a loop allows you to do something over and over and over again. Okay, so those are the different types of statements. When you try to solve a problem, you have to first identify the steps to solve the problem. Does it involve something that is repetitive? Do I have to do something over and over again? Because if that is the case, then you know that you need some kind of a loop statement. And there are only so many loop statements. Okay, they generally fall into two categories: pre-checking and post-checking. Okay, do you have to do it at least once? That's the big question. If you have to do it at least once, you can probably use one or the other. On the other hand, if it is possible not to even do it once, then you have no choice but to use a pre-checking loop. Okay? Are there any questions? I mean, you won't be asked to write a sorting algorithm or anything of that magnitude in the next class. You'll be asked to solve problems that are more like business problems. Like if your income is more than this amount, apply these rules to calculate your tax. If your income is less than this amount, apply these logic to calculate your tax and stuff like that. Okay, well let's use one example. Okay, let's try to solve one problem. I'll just kind of go through it step by step, and so that we have. It serves two purposes. It helps to illustrate how to approach a problem, and also a refresh of all the concepts that we have learned so far. So we'll go ahead and do this part. Okay, so what we can do is to say, let's make an assumption first. Assume array C stores the values of each currency unit. So in the United States, C bracket 0 is going to be 1 to represent 1 penny. C bracket 1, the second element, is going to represent the value of 1 nickel, which is the next one up. So that's going to be 5. C bracket 2 is going to represent a dime, which is 10 cents. C bracket 3, you guys know what it is already. What is it? A quarter, which is 25. C bracket 4 is a dollar bill. 100 cents. Okay, so we only want to represent things, using the smallest possible unit. So this way we don't have to use fractional parts. What about C bracket 5? Just all the common ones. I know there are $2 bills. $5 bills. Okay, so and then you have $10 bills, and so on. Okay, so this is given to you. This is already done for you. Okay, your program. Use your program will populate values in array V so that let's see. I'm trying to think of how to express that. Okay, so that this is how I would do it. So V bracket 0 times C bracket 0 plus V bracket 1 times C bracket 1 plus V bracket 2 times C bracket 2 plus blah 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 represents a particular value K using the least number of coins and bills. Okay. In other words, you're writing a program to automatically, generate the change of a particular, amount. Okay. So how would you do this? Well, first of all, you do it by hand. Okay. Let's do it by hand first. So let's just say that we only deal with all the way up to $10 bills. Okay, and the amount is always guaranteed to be easy to represent up to $10. Okay, so let's take a look at $6.79. Okay, so my K is 679, without thinking, using the concept of algorithms, without expressing things as loops, conditional statements, or assignment statements, just do it in your head. How would you approach this problem? Okay, where do you start?
Find the largest bill you can fit in.
Okay, find the largest bill that you can fit in, and if you just eyeball this, which one is it going to be?
5.
It's going to be a 5. And how many of those do we need?
1.
Just one. Okay, so you just write it down. You just say, okay, v bracket 5 is going to be 1 because 500 is the largest C bracket something that fits K. Okay. I'm just using very loose terms here. I'm not even trying to use all the comparison symbols and whatnot, because this is the first run. This is the first time we encounter this problem. We just want to we don't want to spend too much time to express what we are doing so that we lose our train of thought. Okay. So what else do we have to do?
Next largest count.
Okay, the next amount. Okay, but how do we get to?
We gotta subtract.
You got to subtract. Oh, very good. Okay, so what we can do is now to say that K equals to what?
679 minus 500.
Aha. Okay, 679 minus 500, which is 179, because $5 is taken care of. Okay, very good. So with a remaining of 179 cents, which one should we pick?
The dollar.
$1, because we are using the same logic here. So we'll say v bracket 4, in this case is it 4? Yep. Is 1, because 100 is the largest C bracket whatever that fits K at this point, because K is now reduced from 679 to 179. Is that making any sense so far? So we are just using this logic, step by step, and then we say K now equals to 179 minus 100, because another 100 is taken care of. Okay, so what do we pick next? Now that
C bracket 3.
okay, so v bracket 3 equals to what? 3.
3, yeah.
Because 25 is the largest C bracket something that fits K, and 3 can't fit in K. So now we have K equals 79 minus 3 times 25, which is 4. Okay, and you just keep doing this. Okay, so the next one is going to be v bracket 0 equals 4, because that's the one left. Okay, that's the last one.
Yeah.
Okay, so after doing this by hand, first of all, have we identified whether if you look at the overall algorithm, does it involve doing something over and over again? Are we doing something repetitively?
Yes.
We are. Okay, very good. So that means we have to use some kind of a loop. And when you have a loop, you have to specify when do you get out of the loop, because it is very, very seldom that you want to get stuck in an infinite loop. Okay, sometimes you do. You have some very special applications. You want to get stuck in an infinite loop, but most of the time you want to get out of the loop at some point. So when do we get out of this loop?
When K is
When there's nothing left to change, right?
I would say equal to or less than.
You mean like this?
Yeah.
Less than or equal to?
Well, why do you want it less?
We don't want to be giving them more than they.
What if there's still money due or whatever? I mean,
If it is already owing you money, you don't want to go through the logic at all.
Oh, okay.
That's basically your rationale. Yep, that's fine. That's cool. Okay. Okay. Well, this is a good starting point already. Okay, because by identifying that K is less than or equal to 0 or equal to 0, okay, depending on how you look at it, that part depends on the input. So this is one place. If it is not clear then you have to ask your professor and say, will I get k that is less than 0 to begin with? That would be a good question to ask. If your professor says, no, k is guaranteed to be 0 or more, then you can just say k when you can exit when k equals to 0. So this is what I mean when I said you have to kind of think about it, do it by hand, and think of, okay, do I really understand whether I can do it this way or the other way? Okay, but this is a good starting point because by identifying k is in the condition of the loop, you know one thing for sure: the loop has to change k. Is that making any sense?
Yes.
Because if the loop does not change k and k is greater than 0 to begin with,
It'll
then
always go.
exactly it will never end. Okay, so that's a very good thing already, is to identify that k is somehow going to be changed in the loop. And in fact, we know something for sure too. We know k is going to become smaller and smaller, okay, because that's how you can approach 0 as you go through more iterations. So those are the things that is going through my mind when I try to solve a problem like this. Okay. So the next thing we want to do is to go through this loop here and say, in the loop, what am I supposed to do? Okay. And then you go back to your steps, go back to your own steps here and say, what am I doing here? With every iteration of the loop, you are going to look at a particular currency, right? Okay, you're looking at $10 bills. How many of those $10 bills do I need? You're looking at $5 bills. How many of the $5 bills do I need? And so on. So how do you do it? What do you do per iteration? This is what we do per iteration. Okay, we figure out how many of a particular bill of coins do we need. How do you do that calculation? So let's say, okay, so in this case here, we have to be a little bit more careful. So we'll say, I controls which element of array C we are dealing with in an iteration. Okay, I don't really care about the initialization of I at this point. I just want to know what am I supposed to do with I. One thing I have to do is to specify what is V bracket I, which is the number of $10 bills, the number of $5 bills, and so on and so forth that I need. How do you do this calculation? In other words, how do I figure out this is 1 here? How do I figure out this is 1 here? How do I figure out this is 3? And how do I figure out this is 4?
Well, you start at the end, right?
Hmm?
You start at the end of the array that you're given.
I don't care which n I'm starting with. I'm just saying that if I'm looking at C bracket I as my current currency, how do I know how many of those do I need?
Oh,
I don't even care which n I start with.
You divide k by c b bracket I.
Very good. Okay, so we do that. We say k divided by c bracket I, but that can come up with a fractional number. And I want integers,
mod.
right?
We have to use a mod equals 0 or whatever, right?
You take the floor.
Go mod.
You just take the floor. Mod has nothing to do with this. Well, not yet. Okay, mod comes in handy in the next operation. Okay. Okay, is that making any sense? We have this much amount, as a change.
So if we find out it's like 1.79, it'll just say 1.
Yep. Mm-hmm.
Okay.
Yep. Okay, so this makes sense so far because we are looking at a particular currency unit and we want to figure out how many of those do we need without the fractional part. Okay, so now that's good. That is cool. But yet, k is not modified yet, right? So how do we figure out k? What is the remaining portion that we have to deal with? There are 2 ways to do this. One way, which is, the kind of, I think this is the more obvious way, is k gets k minus V bracket I times C bracket I. Does that make sense? Mm-hmm. Because we just figure out that it will fit at least it will fit V bracket I many of these bills or coins, so we just have to deduct that much from k to get ready for the next iteration. Is that working out so far? Mm-hmm. Okay. But the other way to do this, so we can say we can also do it this way. We can say k equals k mod as one of you suggested, C bracket I. It will work out the same way too. Okay, this has to do with how we put a value into V bracket I, so that these two are going to do exactly the same thing. One involves a subtraction and a multiplication, and the other one involves basically division. But they will work out the same way. Is everybody convinced that they will both work out the same way? Okay. Then we only have one more thing to do, because if I don't do anything, then I is going to be stuck. Okay, I is going to be the same all the time. So I have to remember to add one to I, and to move on to the next one. Now, if I is going to be moved on to the next one, I also have to say, oh wait, this is wrong, right? I just specified the wrong logic.
You're moving from smaller to larger when you want to go from larger to smaller.
Exactly. So we want I to go in the opposite direction, because even this is indicated from the log here. It's indicated when we do it by hand. We start with V bracket 5, then we move on to V bracket 4, then we move on to V bracket 3. So that tells me that per iteration, I should not be increasing I should be decrementing I, so it goes smaller and smaller. Very good. So, so we figured out quite a few things in this one revision of the code. Okay, but we are not done yet. We're not quite done yet. So now the big question is, how am I going to initialize I? Where do I start with I? I don't want to say 6 or 5 or anything like that, because the array, the size of array V can change. In other words, bar V bar minus 1. Very good. So bar V bar minus 1 is a good starting point, because now if someone throws in $20 bills, $50 bills, and $100 bills, I don't have to change the code of the program, because the array has changed its size.
In C.
C. Very good. Yep. Because C is the given array, but V has to have the same size. Otherwise, the program would not work. Now V has to have the same size as C, because otherwise, this one here won't work. Okay, but it's really helpful to depend only on the number of elements in V or C, because they both have to have the same number of elements. So they will both work.
Which does it matter? Which way would the...
It doesn't matter in this case. It is better to start with the C, because that's the array that is initialized, but V must have the same size also in order for this statement not to crash. Okay, so we are almost done. We only have one more step to do, because we really don't have a construct called loop and loop. We have to decide now whether to use a while loop, which is a pre-checking loop, or whether we want to use a repeat until, which is a post-checking loop. So this is when this is when this comparison comes in handy, because if k can be less than or equal to 0 to begin with, then you don't want to go through even at least one iteration.
So you need a pre-checking loop.
So in that case, a pre-checking loop. So now we just copy and paste this one more time and change it into a pre-checking loop, which means while what?
X is greater than 0.
While k
Or
is
K
greater than 0. Do the following. Exactly. So that means if k is 0 to begin with, I don't do anything. If k is negative to begin with, I don't do anything. I only do this when k is greater than 0. Okay, and this will work just fine, with all the different values. So now you guys can make those change machines at Safeway, to calculate the number of coins to spill out.
What I need is one to make one that will recognize crumpled dollar bills. That'll be worth the money.
To recognize bills?
Crumpled dollar bills.
Crumbled dollar bills.
Because the problem is if it's not flat enough, it doesn't recognize it, or so you have
the
to
machine
flatten
spits
it
it back
out.
out.
Mm-hmm.
So
I think most of the vendor machines are fairly good now. No, they're still very
Parking
picky.
machines.
I work with some of those machines every single day, and now they're not.
then I get. Now, what kind of problems, how will what kind of crumbling, will stop it from working? Just about just a minor crease or?
No, they've gotten a lot better. Like they used to have to be really flat,
Mm-hmm.
when they first came out, but now still, there's, if you just shove $1 in your pocket and then try and do it, it won't do it.
Mm-hmm.
How do those things work?
How do they work? I think it's pattern recognition. If they look for specific patterns that are, specific to bills. What I'm interested in is, how can they tell? How can they distinguish between, counterfeit bills from actual bills? I mean,
Well,
It's gotta be in the camera that reads it or something. There has to be some kind of powerful camera that can see differences that counterfeiters can't add in.
Should Wikipedia for it?
the older ones,
You don't have time for that.
the older ones, they can't recognize like the newer like $5 bills or the newer $10 bills with color in them.
mm-hmm.
They have a hard time.
Has anyone seen the new 100 yet?
We don't
I've
like
seen
that,
a,
right?
I've seen a picture of the new 100, but
I think they just started printing in February.
okay.
That's such, you can't even get an actual one, see a picture of it.
But-
You can't even see the face value, you can't even see a face picture.
But the funny thing is, in the United States, we still use vending machines and stuff like that. In Japan, they don't do that anymore. What they do, everything is their cell phone. Their cell phone is everything. When they pay something, like out of a grocery store, or even vending machines, they just walk up to the vending machine and all they have to do is to use their cell phone to talk to the vending machine and basically punch a button to agree to pay a certain amount, and and that's it. They
So
don't.
then they can track
What
every
happens when
pack
the
of
battery
gum
goes
you
dead?
buy. And
They
all
sure
this.
can.
You'll be hungry for a while.
I prefer actual, cash. Thank you very much.
Yeah, what happens when your battery goes dead? What
They
happens
can
when you
track
drop
cash
your
now,
cell phone
too.
in the toilet?
Yeah, they can
It's not
track cash.
tracking so much as easier to keep safer.
Mm-hmm.
Your cash right now can't get a virus.
But the thing is if if you drop your cell phone, if it's passworded or something, nobody's gonna. But if you drop a $10 bill, who knows whose $10 bill that is?
See, now if you drop your cell phone and it's passworded, the password can be either bypassed or broken, and there goes all your information. You drop a $10 bill, all you lose is $10.
You drop your cell phone, you just lost your cell phone.
But there's a certain device, it's called located. Okay, it's a locator. I think it's locator. That's the name of the product. And what it does, there are two things to it. One is a little dongle thing that you can attach to your cell phone or something like that, and the other one is kind of like a handheld of the size of a cell phone. So when the dongle or when the tag is outside of a certain range from the other part, it will just cause an alarm. It will tell you that that thing that you attach your tag to is out of range. Okay, so it's a pretty easy RF technology. If the signal strength is below a certain threshold, it will cause an alarm.
I read about something on the internet yesterday that's it's a new feature. If you get your camera stolen,
Mm-hmm.
it'll search the internet and it'll find pictures taken with that camera. And then like if somebody else takes a picture with your stolen camera
Right.
and puts it on the internet.
Because the
it traces it
EXIF
back.
tag identifies the camera itself. But what I'm thinking is, if you put all your personal information, all your private stuff, your passwords and whatnot on your cell phone, you can do something like that. It can be as simple as a Bluetooth thing, because a Bluetooth is a RF, radio frequency kind of device, and your cell phone can always monitor the signal strength from a particular Bluetooth device. Okay, it can be your headset, can be something else. So when the signal strength drops below a certain level, you can have your phone to automatically lock itself up completely.
Or self-destruct.
Shorting out the battery terminals can be a little bit dangerous, and you might have problems getting it on the airplane, at that point. But it's easy. The technology is easy to implement because Bluetooth is radio frequency already, and all it takes is the logic to monitor the signal strength from a particular Bluetooth device, and if it drops below a certain point, have the
You
OS.
have to carry two things all the time.
But most people already have those two things all the time.
It's not going to be that heavy. It's only looking at like a pound or two.
Well, I guess if it was like the size of like, you know, like maybe if it was a keychain.
Yeah.
and
Yeah, but the Bluetooth, device, you have seen, the Bluetooth, headsets. I mean, they're
they look
really
retarded
tiny.
on people.
Hmm?
But that look retarded on people. I've seen that.
But this can be the keychain size. I mean, you're talking about, something that is maybe half or 1/4 of the size of your fob for your car's remote. And once you have that, and you accidentally put your cell phone somewhere else, you put your cell phone into I am lost, I'm potentially stolen mode, and it can just broadcast a certain signal and say, okay, I'm here, I'm here, I'm here, I'm here, and have your cell tower, have your cell phone company to help you track down the location. And potentially, you can go back and your cell phone will still be there, but you can lock it down to the point that people cannot use it, cannot access the information on the cell phone anymore.
I know, like for Sprint, like if you lose your phone, people cannot reactivate it. So I think they're making progress in that sort of department.
Yeah, you can put a timer too. You can put a timer like within 30 minutes or 2 hours or whatever. If the phone is not found or reactivated, just do a low-level format of the flash drive on the cell phone. So
Take it all off.
yeah, take it all off. That can be done. Okay, so does anyone want to learn how to do Android applications?
Okay, then I might stick around for that, but.